Hello everyone. With this video, I'm going to start a new chapter, Game Theory. This is for Intermediate Microeconomics 2. For more advanced game theory lectures, please check out my other watch lists and videos. So, what is a game theory? Well, game theory is a methodology to study strategic interaction. What do we mean by strategic interaction will hopefully become clearer. Well, so let me start with how we mathematically represent a strategic environment or game. Well, we need 4 ingredients. The first one is a list of players. We have to have at least 2 players, at least 2 or more. Well, if we have only 1 agent, it's not really a game, it's just a single person decision problem. So for that reason, we have 2 or more agents interacting with each other, all right? Second ingredient that we need is the set of actions. So we need to sort of describe what the set of all actions available for the players, okay? Sometimes we call them strategies, sometimes we just call them actions. For example, if it is a chess, the actions are known. If it is a rock, paper, scissors game, the actions are known. You see what I mean? Okay. Well, the third ingredient is the payoffs. Well, for the payoff, to make it more clearer, well, first of all, each action a player takes, along with the actions of all the other players, will lead to an outcome, all right? So usually, in a strategic environment, it's not just one player's action, but all the players' actions together determines an outcome, all right? Well, then the agents should have some preferences over the outcomes, like which outcome is the most preferable, second preferred, third, etc. So basically some sort of ranking over the set of outcomes. Usually we're gonna use a utility function, a profit function if the players are firms, but nevertheless we're gonna call those preferences over outcomes as payoffs, all right? And then the fourth ingredient is what the players know about the game, about their opponent's behavior before they act, before they make a choice. All right? Well, we are in this course going to talk about 2 class of games. The first one is what we call simultaneous move game, or sometimes we call it one-shot game. And then we will also talk about extensive form game or sequential move game. So in every game, in these 2 different families of games, players are supposed to know different things about their opponent's actions. But in this course, we will talk about perfect information games in the sense that and the complete information cases where all the players know everything about the game, all right? As we move through, I will going to make it clearer. So now let me give you an example, all right? So here is an example and how we sort of create a game. So I have 2 players, Alan and Ben. They get caught for jointly stealing a car, all right? So the players, we usually denote it by N, but it really doesn't matter. Alan, I will later refer it to as player A, and then Ben, I will later refer it as B, player B. So Alan and Ben get caught for jointly stealing a car, all right? The police suspect that they were also involved in a hit and run, but the police does not have the evidence to convict them on this charge. So these 2 prisoners are interrogated in separate rooms. Alan and Ben each have 2 possible actions. All right, so the actions. Well, what are they? Remain silent or confess. All right. Well, so this is just a sort of very simplistic environment, obviously. In reality, players may have more than 2 actions. But for simplicity, let's assume that these 2 guys, A and B, have only 2 actions available to them. Remain silent and confess. Well, the question, the story gives you an important information about what the players know about each other. They are interrogated in separate rooms, so they don't observe each other's actions before they make a choice. So that's what we call a simultaneous move game. All right, it does not. So let me say it, write it. Simultaneous move game. So sometimes you can take that simultaneity literally, meaning that the players move exactly at the same time. But the general idea is the following. When one player makes a move, chooses an action, he or she does not know the action of the other players. All right? So that's what we mean by simultaneous move. All right, so the set of players, the set of actions available to, all the actions available to these players. So these guys have no other actions, all right? If they were, I would have mentioned it. All right, so they have only 2 actions. You cannot choose a third option because it's not available. You have to choose one of those. For example, I can't make a choice is not a choice, okay? So that's very important. Are you going to remain silent or are you going to confess? Well, you have to pick one of them and only one of them. You can't say I choose both or neither. That's not a choice. Okay. Well, the third ingredient, we sort of talked about what the players know when they act. Basically, they don't know each other's action, but they will know. That's sort of the underlying assumption. They will know how many players there are. Right? It's Alan and me, for example, if I'm Ben. And here are the 2 actions available to us. We are choosing simultaneously. So all of those are known. Furthermore, we're going to assume that the payoffs, the outcomes, and the preferences over the outcomes are also known by these 2 players, commonly known. So now let's talk about the payoffs, because that's also a very important ingredient of a game. So in this game, there are 4 possible outcomes of the game. All right? So the outcomes. Well, first, the story talks about the outcomes and then next talks about sort of the preferences over those outcomes. Well, the first outcome is basically both Alan and Ben remain silent. Okay, they both remain silent. Well, Alan confesses and Ben remain silent. Okay, or the Alan remains silent, and Ben confesses. Sometimes I write Ben, sometimes I write B. Sorry, don't be confused. And both A and B confess. All right. Well, I mean, because there are 2 actions, there are 4 possible outcomes, right? That makes sense. And so they either both remain silent or they both confess, or one confessed and the other remains silent. Okay, so, well, what about the sort of the preferences? Well, here the story tells us that these players care only about the jail time they're going to get as a result of those outcomes. All right, so the only thing that matters for them is the number of years they're going to spend in jail. And the outcome basically determines who will spend how much time in the jail. So if they both remain silent, in this case, then they each go to jail for 1 year for grand theft auto. All right, so 1 year jail. Okay? If they both confess, each goes to jail for 2 years. 2-year jail. All right. If one of them remains silent and the other confess, so these 2 scenarios, then the one confesses goes free while the one remains silent goes to jail for 4 years. So if A confesses, the Alan confesses, and Ben remains silent, while the one confesses goes free. All right. So A, 0 year in jail. All right. So going free, well, that means 0 year in jail. However, B gets 4 years in jail. All right? And here the opposite, because the A remains silent, B confesses. So the B is going to get 0 year in jail, and then A gets 4 year in jail. Okay? So, and remember, the only thing that they care is that the jail time. So jail time. Both Alan and Ben are trying to minimize their own jail time. So Alan trying to minimize his own jail time, and Ben is trying to minimize his own jail time. So they don't care about, for example, if Alan is the subject, the Alan does not care about the Ben's years in jail. All right, so they are selfish in that regard. For simplicity, all right. Obviously, we can allow what if they do care about each other's jail time. Maybe their payoffs are more, preferences are more complicated. I mean, they not only care about their own jail time, but also if they're a friend, the friend's jail time. All right. So some sort of aggregated jail time matters for them. So that could be the preferences. But for this example, no, it's very simple. All right. And each player cares only about his jail time. Okay. Well, then the question is, well, how can I represent this as a game? All right. And then the next question we will ask, and in fact, for the rest of all these videos, we're going to focus on how to solve those games, or sort of how to make a prediction out of those games. So we're going to talk about several solution concepts like dominant strategy equilibrium, Nash strategy equilibrium, a Nash equilibrium, mixed strategy Nash equilibrium, etc., etc. So let's first try to represent this as a simultaneous move game. What does it look like? Well, by the way, this is a very standard prisoner's dilemma game. All right. And the way we represent it is, simple. We call this normal form representation or matrix representation. Okay? So it's going to be a 2x2 matrix. Why 2x2? Well, I have two players. So the matrix is going to have rows and columns. So I'm going to put one player as a row player. So here I'm going to call Alan as the row player. I mean, he is basically choosing a row. He's determining which row the outcome will occur. And then Ben basically choosing which column, in which column the outcome will occur. All right. So Ben is the column player. And it's 2x2, I said, because two players, okay, I got it. And each player has two actions. So therefore, Alan can remain silent or confess. And similarly, Ben can remain silent or confess. All right? So because each has two available actions, it's therefore 2x2 game. Okay? Well, and as a result of this, I have 4 boxes, representing 4 outcomes. So now I'm going to put the payoffs. And remember here, the payoffs are the years in jail. So that's what they care. So here's the how I sort of put those outcomes and the payoffs into the matrix. In the payoff matrix or the game matrix. So both Alan and Ben, if they both remain silent, all right, so basically I'm talking about this box, each will get 1 year in jail. All right, so 1, 1. So that represents, the first number represents the row player, and the second number represents the column player. So therefore, whenever you see a tuple, all right, the first number is the payoff for Alan, and the second number is the payoff for Ben. Always. All right, so you don't switch that. So I mean, put the first number for Alan, and then here put the first number for Ben. Don't do that. So be consistent, all right? And then both A and B confess. So basically the lower right box. So they each receive 2 years in prison. So 2, 2. So 2 years for both. Well, if Alan confesses, all right, but Ben remains silent, so basically we're talking about this box, the Alan is going to get 0 years in jail. Remember, Alan is the first player, and Ben is going to get 4 years in jail. Okay? And then finally, if Alan remains silent and Ben confesses. So Alan remains silent and the Ben confesses. So basically, well, the only remaining box is this. So the confessing player B is going to get 0 year, and then the other player, the one that remains silent, gets 4 year. Okay? So this is exactly how we fill out the boxes. Well, then the next question is, if this is the game, what is the optimal strategy for the players? Remember, each is trying to minimize his jail time, all right? So here, when you look at, oh, by the way, one more thing about what the players know about the game when they act. So when Alan and Ben, before they make a choice, they already know that this is the game. So, right? So you can imagine that they both see this matrix. You know, Alan knows that he's basically determining the rows. The Ben knows that he's determining the columns, and the payoffs will be as such. So this is common knowledge between Alan and Ben. So then they're expected to make one choice. You either remain silent or confess. So think of this as you have to write down your strategy on a piece of paper and then submit this to the police. All right? And then the police takes those written pieces together and then reveals the outcome. And it says, oh, you know what? Alan remained silent and Ben confessed. Here is the outcome as a result of this. And so that's the end of the game. The other assumption, sort of the implicit assumption in simultaneous move games, there is no future. I mean, once they play this game, the game is over. All right? So, I mean, you can imagine a scenario where these two guys are friends, and so they're going to interact with each other after the game. Well, if there is such, relationship, obviously it's going to influence their behavior in the game. So you better put that relationship, the relationship afterwards, into the game somewhat. So it doesn't appear here. That basically means, therefore, it's sort of an assumption, these players are actually, play this game and die. All right, so let's imagine this way. So they don't need to worry about what if I play this way and then what happens afterwards, after the game. Will my opponent punish me, for example? So there's no such concerns because you're going to play the game and you're going to die. That's the end of the life for you. Okay? So given all those sort of constraints, okay, the question is, what would be the optimal strategy for these players? Obviously, the optimal or the most preferred outcome is for Alan is to confess, but the Ben remains silent because only in this case Alan gets 0 year in prison, which is the most preferred outcome because remember they're trying to minimize the number of years in jail. So the 0 is the best for that reason. 1 is the second best, 2 is the third best, 4 is obviously the worst possible outcome for any of those players. And by the way, this is a symmetric game in the sense that if you put a mirror on the diagonal, you'll see that the payoffs are in a sense in a reflection. All right, so the mirror here 1 and 1, mirror here 2 and 2, mirror here 0 4 4 0. So it's like the perfect image. All right, the mirror image. So it's a symmetric game. So it's fine if I just talk about one player. When I talk about the most preferred outcome, the least preferred outcome, etc. But when it comes to the solution of this game, obviously the players cannot ignore the other player because the other player's action also determines your payoff and your well-being. So that's what we mean by strategic interaction. All right, so it's like I'm making a choice. Yes, for example, as an Alan, I am, choosing to confess. But the thing is, I'm not going to get the 0 payoff unless my opponent remains silent. If it happens that my opponent is also confessing, actually I'm going to get payoff of 2. So my payoff depends not only on my action, but also on my opponent's action. All right? By the way, for just sort of a note, in this course, Intermediate Microeconomics 2, we will talk about 2-player games, mostly 2-action games, maybe a bit 3, 4, 5 actions, or sometimes maybe infinite actions. For example, in the Cournot game, we did actually talk about infinite actions, right? Each firm is choosing quantity. But nevertheless, we're going to focus on 2-player games because they're easier to work with. All right, so in this even simpler game, like 2 actions, 2 players, remaining silent is my second best, but again, it depends on what my opponent does, right? So I'm going to get 1 only if my opponent remains silent. And if I confess, if my opponent confesses, I may actually end up with a jail time 4, which is even worse. So here, you cannot just it's not like Monopoly is choosing its quantity, right? I have a profit function, I choose quantity to maximize profit, so it's not that straightforward. Your action will, yes, determine your payoff, but the opponent's action will also play a very important role in determining your payoff. So therefore, you should take this strategic interaction into consideration. So I'm going to make another movie for this, but let's talk about the dominant strategy for this specific game. So in this game, there's a dominant strategy. So what does that mean? That means there is a strategy for each player which always yields a better outcome than the other strategy. All right, so I don't know. Give yourself a moment and think about it. All right, before I give you the answer, pause the video. All right, look at this game and try to find the dominant strategy. Again, what's the definition? I'm not giving any formal definition, but the dominant strategy, we sometimes call it strictly dominant strategy. It's a strategy that whatever your opponent does yields you, that dominant strategy gives you higher payoff than your other strategies if you have more than 2. All right, so pause the video and think about which strategy is dominant strategy and why. Okay, so here, remember, these players are not trying to maximize the numbers. They are, in fact, trying to minimize the numbers you see there. So that's one trick. And so here, clearly 0 time is better than 1, and 2 years in jail is better than 4 years in jail. So which column is going to occur? The outcome will occur in one of those columns, right? It's going to be either in column 1 or in column 2. That you cannot determine because the column is chosen by your opponent, Ben. All right? So as player A, you only determine where the outcome, which row the outcome will occur. When you, for example, choose the action silent, you determine, all right, you guarantee that the outcome is going to be either 1, 1, all right, or 4, 0. All right? It's not going to be 0, 4, or 2, 2 because you choose silent. So you choose in which row the outcome will occur. But your opponent determines which column. So you, as Alan, do not know which column your opponent will be choosing. So it could be this one, it could be this one, that you don't know because you're choosing simultaneously. So what you're saying is you're comparing 2 actions. So the silent gives me 1 year in jail versus confess gives me 0 year in jail. So when Ben chooses this column, the first column, confess is a better strategy than silent. But the question is confess still a better strategy when my opponent Ben chooses confess? Well, let's check. If my opponent chooses the confess, I mean the second column, well, confess gives me 2 years in jail, whereas remaining silent gives me 4 years in jail. So confess is still better. So whatever my opponent does, whatever Ben does, confessing is actually giving me higher a better outcome. All right. So therefore, Alan should never play silent. Okay, because confess is a dominant strategy. Dominant strategy for Alan. Well, remember I said this is a symmetric game. So it should be the case that the confess is also dominant strategy for Ben. And how do I know that? Well, I'm sorry, I already crossed this row. But if you're Ben, and well, that means you're choosing the columns, but you don't know which row your opponent will be choosing. So therefore, you're comparing the second numbers in each sort of across columns, right? So for Alan, you were comparing the first numbers across rows because you're the row player. And as a column player, you compare the payoffs in across the columns. So if you remain silent, 1 year in jail. If you confess, 0 year in jail. So across columns, confess is clearly better. Of course, this is true if your opponent remains silent, but it's also true if your opponent confesses. I mean, the confessing for you is better than remaining silent because it gives you less years in jail. So you know what? Confess is also dominant strategy for Ben. So therefore, Ben should not remain silent. So that means they should both confess. And hence, this should be the outcome of this game. We call this dominant strategy equilibrium. Dominant strategy equilibrium. All right? And it is confess, confess. So they both confess, and then the payoff, 2 year in jail. All right? Okay, so that's basically the prediction of this game. Few questions may arise, which is pretty natural, and they should. It's like, well, here there is an outcome 1 year in jail, so it's like collectively that's a better outcome than 2 year in jail. It's like, why those two guys do not, think about that and remain silent? Well, the problem is they cannot coordinate. When they choose their actions, they are completely free. They are in separate rooms. They don't know each other's actions, and they don't trust each other. They only trust their incentives. All right. So let's say I'm Ellen, and I know that it's like 1 and 1 is definitely better than 2 and 2. So if we play this game as predicted, we're going to end up, 2 years in jail. So there's got to be a way to convince my opponent that there is actually a better, outcome for both of us. But the problem is I can't call him, I can't communicate with him. But even if I had the opportunity to talk to him before playing this game, oh, Ben, we should remain silent because we will end up 1 year in jail as a result of that. So remain silent, don't say anything. And then we go in separate rooms, and then we basically write down our sort of action. It's like, what do you think Ben is going to do? Is he going to choose silent? Well, let's say he does. So Ben, let's suppose, and you know that he's a trustworthy guy, all right, whatever that means in this scenario. So he's a trustworthy guy. He's going to write down remain silent. So now think about what you would do. Well, remember, you make a choice here, and only thing you care is minimizing your jail time, and then you die in a sense. There's no future. So there's no shame of doing the right thing for yourself. All right? So even though you communicated with Ben and said, well, let's write down silent, you will actually choose confess because if you believe Ben is going to remain silent, you should be actually confess. Because in this case, you're going to get 0. But then you may say, oh, but if I do that, my opponent is going to get 4, which is like, I'm going to feel terrible about myself because I promised my opponent about the action I'm going to choose, but then later I don't follow that. Well, remember, there is no future. Once they play this game, they get the payoffs and then they die. So you're not going to, or there is no shame or anything because they don't care about shame or any other psychological effects. The only thing they care about their years in jail. All right. So here the objectives are very clear. Not realistic, I know, because people usually care about doing the right thing, being an honest person. So these are being trustworthy, etc. So these are all valuable things. But here you don't have those concerns.